Hi everyone. Thanks for being here. Before we start, let me ask you something. How many of you are running more than one Kubernetes cluster today? And how many of you actually enjoy doing releases across all of them? At some point, Kubernetes stops being just a class problem and starts becoming a coordination problem. You are no longer just deploying an application. You are coordinating releases across regions, clusters, and environments. So today, I want to share how we approached this problem, how we moved from class-level thinking to a more scalable way of doing progressive delivery across clusters. Let's get started. I'm Ryan from That Is Cloud Music, and this is my partner, Zhang from Huawei. Here's today's agenda. The presentation is divided into 5 parts. Look at the right picture. It shows the basic structure of our inner CI/CD platform. Starting from 2020, when we first adopted GitOps and Argo CD, till now, there are thousands of Argo applications running across multi-region, multi-zone, and multi-cluster. And the scale keeps increasing. Some challenges need to be addressed, like how to make releases safely and efficiently, how to survive a data center outage, how to upgrade Kubernetes gracefully, and what should we do when new regions or clusters are added. First, how to make releases safely and efficiently. We definitely need the trending concept, progressive delivery, which means gradual release plus continuous verification. The typical mechanism include Canary release and blue-green deployment and so on. As the picture shows, more and more traffic shifts to new version of workloads, while your promotion or rollback decisions are made according to metrics observation. Now, how can we practice progressive delivery? Argo rollouts is a mature option which extends Kubernetes deployment strategies, but usually it can only come into play in the class scope. Modern delivery is no longer a single cluster. Today's applications are commonly deployed across multi-clusters or regions to get high availability and disaster recovery ability. Progressive delivery must evolve from class rollout to global release orchestration. Let's see what Argo provides to solve multi-class release problem. There's a bad feature called progressive syncs introduced to application set. This enables staged synchronization of applications. For example, DV first, staging last, production last. It can help make the release executed cluster by cluster automatically with the check of healthy status of applications in each cluster. Now, we got class scope progressive delivery tool, Argo rollouts, and progressive syncs feature with application set to achieve release orchestration in a way. However, there are some problems need to be concerned. First, application exposure, which could lead to performance issue and complexity of management. Second, class-aware route tracking. We commonly have different roles in our teams, right? Developer, platform engineer, SRE team, and so on. So the developers need to know the underlying infrastructure of clusters, which is not necessarily in most of time. Third, pause and resume multiplied by clusters is not a good news to the efficiency of release. Last but not least, missing of cluster maintenance and failover ability. What are we supposed to do if a new cluster joins or an existing cluster gets into unhealthy state? For developers, instead of letting them know which cluster is currently rolling out, which cluster is paused, and which class still needs to be resumed, we want them simpler to know is wave 1 completed, Can we move to wave 2? And has this release batch finished? Class level issues should be invisible to them. Leave the cluster's maintenance to SRE. We need a brand new releasing model. We call it Cluster Abstracted Waves Releasing Model. To achieve this, we need a new framework that supports wave-based progressive rollout across clusters. Next, I'd like to invite my partner Zhang to introduce how we build this framework and how it works in practice.
Okay, thanks. Now let's look at Karmada. Like Argo, Karmada is a popular self project, but it focuses on different goals. Multi-cluster management is fully compatible with Kubernetes native API, so it means it works perfectly with the existing Kubernetes tool. It also makes integration with Argo very easy. With Karmada, managing 100 clusters is as easy as managing one. So how does Karmada work? Here are 3 simple user-facing API. The first one is the resource template. It's seen as the Kubernetes API. You don't need to change your YAML files when you migrate your application from a single cluster to Karmada. The second one is the propagation policy. It defines how to distribute the resource across clusters. The third one is the override policy. It handles different settings for different clusters. When you deploy a template and the propagation policy, Karmada will create a resource banding. It tells the system which cluster to use and how many replicas to run. Then it applies the override policy and syncs the object to the member clusters. But how does Karmada understand complex resources? The answer is the resource template interpreter. Think of it as the eyes of Karmada. It helps the system to see and read the customer resources, even if they are not standard. The operation interpreter replica is how Karmada loads the desired scale of your application. It extracts the replica count and the resource requirements, like resource request and the ladder selector. Based on this, Karmada can make smart scheduling decisions based on your actual needs. And then, after we deploy, we need to know, is it working? What is the current status? That is where a greeted status comes in. It connects status data from member clusters into one single view. Because of this, tools like argcd can see the status of a global resource in one place. Then, how to tell if an application is healthy? We use operation interpret health to define it. Take a replica set as an example. It's healthy only when the observed generation matches the status generation and all replicas are available. Beyond simple thinking, Karmada is a smart scheduler. It supports cluster affinity and tense. It can group workloads based on their affinity and divide the workloads into different clusters due to their anti-affinity. These features meet many different user requirements. In a multi-cluster world, cluster will fail. But don't worry, Karmada has built-in failover. If a cluster goes down, Karmada will detect it and migrate your applications automatically. This will reduce manual work and keeps your servers highly available. Now, when we combine argcd with Karmada, magic happens. One application is forward. Centralized rollout orchestration is executed in Karmada control plane. Karmada is responsible to dispatch replica sets to member clusters. Let's take a look at the diagram on the right. This shows a full release process use argcd and Karmada together. Imagine we have a Git repo. It contains the manifest of our Argo rollouts. propagation policy and override policies. Once we create a application, Argo CD pulls the seed from the Git and deploys the rollout resource to the Karmada control plane. And the Argo rollout controller will watch the rollout resource in Karmada and create a replica set. Please note, at this stage, Karmada does not create any pods in the control plane. Instead, it uses the propagation policy to sync the replica set to the member clusters, and the member clusters actually pull up the pods. When the replica sets in the member clusters are ready, Karmada marks the status of the replica sets in the Karmada control plane as healthy. This will tell Argo that the rollout was a success. Now, we realize the cluster abstracted releasing model. User can see the release waves. Karmada handles cluster placement and management. Is a perfect practice of separation of duties. Let's see the power of Argo CD plus Karmada. First, we can use the replica dividing. We can divide replicas across different clusters for high availability. Clusters with more resources will get more replicas. Also, we can use override policy for customer configures. For example, you can use different image URL for different regions easily. Usually, when Argo CD syncs a new version, all member clusters will update almost at the same time. But sometimes we need to release in batches. We want step B to start only after step A is ready, right? Karmada makes this possible. It can pause or resume scheduling for specific clusters. When a cluster is paused, changes in Karmada will not sync to it. We use this to achieve a region-level Canary release. For example, imagine we have 10 replicas deployment across 3 clusters. First, the platform will resume class 1. Karmada will dispatch the deployment resources to class 1. Once the 3 replicas in class 1 are ready, the platform resumes class 2. And we will repeat this again and again until the whole rollout is complete. Safe release is important, but what happens if a class fails during or after the rollout? Sometimes clusters become unavailable due to the network issues or control plane features. To ensure the SLO of our applications, we can use the Karmada's failover feature. It automatically reschedules applications to healthy clusters. We don't just care about the results of a single release. We provide continuous maintenance to ensure high availability. Now Ryan is going to walk us through a full release flow using Argo and Karmada. Ryan, over to you.
Thanks. Okay. All right. Let's see how we can roll on my local Mac. It's structured like the picture shows. 3 Kubernetes, all essential components installed in advance. To avoid any live demo surprises, we will show it through a recorded video. And if you are curious about the setup, feel free to come chat with us after the session. Here, we can see the Argo URL page, and I'm sorry. Now, we can see Karmada is registered into Argo as a normal cluster. Let's create a new application. And the demo project has been created in advance. Now the application has been created. Let's see the resources that Argo is gonna deploy to Karmada. We can see the replicas is 10, and we got these steps. Override policy is used to add extra environment to replica sets. And the third one, propagation policy, which is used to specify the scheduling policy. And we set it as 1-on-1 for member 1 and member 2. It's a static weight. Now let's make the initial synchronization. And a new replica set is created. 10 replicas, and resource bounding is created automatically by Karmada. It records the result of the scheduling. And it records the status of each member's resources. Wait a second. We've got a problem. Where are those CUDA pods? They might get lost. Well, of course not. Karmada provides the ability to help retrieve resources from the underlying member clusters. You can see 5 pods in member 1 and 5 pods in member 2. If you query directly from member 1 cluster, it's the same result. Now, let's make a new release by changing the tag of the image. Now you can see the diff is now a new synchronization. A new version, revision 2 replica set is created with the replicas 2. And the replicas of the old revision has scaled down to 8. You can see from member 1, a new replica set is created, same as member 2 cluster. let's resume the rollout process. The replicas is scaled up to 6. Three for member 1 and 3 for member 2. Let's resume again to the final step. And last, 5 for member 1 and 5 for member 2 with a new revision 2. And that's all for the demo. Finally, let's talk about our journey in the open source community. Our main contribution to Karmada is the built-in replica set resource interpreter. In the future, we will keep improving this platform, focused based on our real needs. We will continue to refine the way Karmada and Argo work together. Hope to give back to Argo, Karmada, and more open source projects. Thank you. Feel free to share any questions or suggestions.
Okay, thanks.
Oh, thank you. Thank you.
Sorry, I would like to know, how do you manage the traffic between all your clusters? I mean, you deploy your applications, right?
Yeah.
But suppose that the rollouts fail in one of the cluster.
Yeah.
Do you integrate service mesh in a cluster way, or any cluster is independent in terms of traffic and?
Okay. In our inner platform, we use the original ZK and the inner gateway. We don't complete the cloud native transformation. So the ports, when the ports is ready, it's registered to the zookeeper, and the inner gateway is responsible to the traffic, for the traffic shifting.
Okay.
Yeah. So we don't use the ingress. Yeah.
Okay. Thank you.
I have a question. I saw you used override policy. For what purpose? Because you have a propagation policy. What's the purpose of using the override policy?
Okay. Propagation policy is a CRD in Karmada. Let me see. Oh, this one. It defines Karmada how to distribute the target resources into different clusters. Okay. We can discuss it later after the session. Sorry. Okay. Thank you. Yeah.